Okay, I think we got everybody in here. Hi, I'm Dr. Fred. I'll be your instructor for Chem 130, GCC specifically, 130. Welcome aboard. I get to torture you for 16 weeks. All right. First things first, though. What I got to do is I need to check to see who's here. And once I call your name, if you would please type your name in the chat so I have record that you are here. So let me go through my list. Okay, how about Devin Burke? Are you here today, Mr. Burke? Okay, there you go.
Yep.
There you go, thank you. Jacqueline Campos. Jacqueline Campos, okay, good, thank you. Savannah Carpenter. Savannah, good. Ashley Contreras. Ashley, are you here? Ashley. What about Devin Day? Devin Day, are you here? Okay, Devin, I see you down there at the bottom. Good. Oh, Brian Duran, is that correct? Did I pronounce that right? Brian, is that Brian or Brian? Okay, I see your name. Gotcha. Kendra Hernandez. Kendra, you're here. Gotcha. Where'd you go? Daniela. Gotcha. About Madison Foley. Good. Judith, is that Gordy? Judith, gotcha.
Oh, yes, it is.
Great. So I apologize if I kill your name. It's not on purpose. Okay, how about Tien Hong? Gotcha, I see you. Daniela Lopez. Miss Lopez. All right, and then Alex Martinez.
Over here.
Gotcha. And Diana Mendoza. Diana. D-E-E, Anna, A-N-N-A. Nope. E-E-A-N-N, Mendoza. Okay, how about Amra Music? Gotcha. Cynthia Perez. Okay. Susan Rice. Good. Lost my list here. Itzel Rodriguez. It said. I-T-Z-E-L. Nope. No. Marcine. Gotcha. How about Norma? Saucedo, Norma Saucedo. Norma, there you are. Got you. Samara. Sanvedian. Samira. Okay, S-C-Y-A-D-I-E-N. How about Heather? Heather, are you here today? Gotcha. Kaylin Smith. Kaylin Smith. K-Y-I-N, Smith. Nope. Okay, how about Mary Lou? Tejida. Mary Lou, you here? There you go. All right. Now, I'm going off the list directly from Canvas. So if you're not on the list, you must be on the list. The only way you can get the link, maybe. Okay. So if you're not, you might shoot me an email and we'll figure it out. Okay. Well, welcome aboard. We have A lot of stuff going on for the next 16 weeks. And what I wanted to start first is I want to go to the Canvas course. Yeah, okay. And I'm going to share my screen. All right. There's a couple of things I want to talk about. If you're new to this, maybe course obviously is open. There's a lot of information here. If you haven't had the time, well, first of all, anybody having a hard time hearing me? I did have a little bit of a technical problem earlier, but if you are, shoot me a little chat here. Maybe it's coming from my end here. But anyway, if you're not done Canvas before, do spend a lot of time in here and get familiar with this. So this is the screen that you will see. So welcome to Chem 130, and Dr. Fred. We're going to talk about chemistry, and like that T-shirt said, T-shirt is like cooking, just don't eat the spoon. Cooking is a chemical reaction. It is. Anyway, more about that later on. On the far left, you see the links. You got the home link, which brings you to this page. Now, I like this page here because in this page, if you scroll down, you will see a course summary, and these are all the assignments listed in their due date. So you can, at a glance, be able to see what's coming up. Okay. Also, you can see that the calendar in the far right column is highlighted, telling you there's something coming up. Okay. Now, obviously, you found the Zoom meeting because you got a link there with the Zoom meeting. These Zoom meetings, if they will work with your browser, you don't have to load the app, but it's advantageous to use the app. So it's not necessary. Most browsers will support the Zoom meeting. So also is a link for the YouTube recorded meetings. Okay, all the meetings will be recorded so you can view them at a later date for your information. Okay. Now our course is broken up in modules. So underneath recordings, if you click modules, we'll bring you to this. Now, let me collapse it for a second here. But every chapter, we got a welcome module. And then after that, every chapter has their own particular module. We'll have, and I got 2 additional modules that we'll talk about. If you go to say, well, the first one, welcome, is kind of just my introduction video, the syllabus, couple of tables that you should print and have access to. We're going to make reference to those tables quite a bit, specifically the periodic table. We're going to use that a lot. And then some videos on how to submit videos to Canvas, because this year we're going to have you do an explanation, or in your words, ask a question and have you respond to them with a short video, nothing lengthy, a minute or so, and then record it and then upload it. Now, if I don't get if you are having trouble with that, let me know, shoot me an email, which reminds me, with respect to emails. Now that we started, I've been answering the other email, my EDU email, because I know in the beginning, we're learning, what we cannot do, so on and so forth, and getting our classes organized. But from this point forward, to contact me, use the Canvas email, okay? The Canvas email. So if you go to the far left, and I won't click it, but in the far left, you have an inbox. And there you have, and click that inbox, it sends you to the email part of Canvas, and there you can send me an email, okay? I have Canvas email hooked up on my phone, so whenever I get an email, I'm notified fairly quickly. Most of the time, I can respond right there on the spot, unless I need a computer, in which case I will let you know. My other email, my EDU, I don't monitor it as often as this one. So I use that as a backup. If for whatever reason Canvas has a shutdown, something's happening, it's not working, you need to get a hold of me, yes, by all means, use the email for my EDU, gccaz.edu email. And obviously, if Canvas is down, I'll be monitoring that one a little bit closer. But official email is through Canvas. Okay. So here's the activities that you need to check out before we get going. Once we are done, you get into the chapter. I'm just going to open up one chapter. In that module for chapter 1, you will have a PDF file. First of all your textbooks are provided for you. You don't need a textbook. All the chapters are in PDF format. This textbook was created by GCC staff and to assist our students to prevent them from having to pay $200-300 for a textbook, which is kind of ridiculous. But so we've been using what's called open resource. So you have a textbook in PDF format per chapter. So we have a link there with an overview of what that chapter is going to be about. Then here you'll see highlighted chapter 1 OER. It's Open Educational Resource Textbook for chapter 1. Okay. Now you have two types of videos. Now, Dr. Kim Smith, who's responsible, who's the head of the Chem 130 classes, who's the coordinator, has created videos pertaining to each chapter. And those are already posted. Now we got them all set up. So you can, and another resource is view her videos. She'll be talking about the same subject matter I am, but it'll be, in her format, if you will. So then in our case, once we're done with the lecture, the Zoom lecture, I will upload to my YouTube channel. And so you have a second set of videos for the lecture that we do during Zoom. So you have a double whammy here, okay? You're able to listen to Dr. Kim and then listen to me concerning material for chapter 1. And that's for all the chapters, okay? Now, if that doesn't work for you, because, sometimes, do a YouTube search of whatever topic you're looking at. I'm sure you're well aware there's tons of videos out there with respect to chemistry, with respect to a particular topic. So listen to other instructors talk about a topic. So, there's a lot of resources out there for you. We also include a worksheet. Okay, and that worksheet is basically work problems for that particular chapter, and it has the answers there, the key. So, work the problems and then check it with the answer. Now, if there's anytime there's a question about these problems, I have no problem with bringing them up in class and we'll go over them. Okay, and then you have the activity. Most every chapter has an activity to complete. A lot of these activities is something you must submit. So it won't get graded right away. I wait until everybody's done submitting something, then I grade them as one group. And so even though you completed it, it may show no grade. You gotta wait till I grade my part, and then the grade will be updated. Then every chapter has their own set of homeworks. It's all online. Excuse me. Short questions, only about 10 points. With respect to homework, with respect to all assignments except exams. Exams are set. Everybody in Chem 130 will take exam 1 through 5 at a certain time. It will be open at a time between noon and 11 p.m. and only open in one day, okay? Now, if for some reason that day doesn't work out for you because of work or other factors, contact me ASAP so we can make arrangements for alternative times, okay? But the homework and the other activities, they will remain open until the end of the semester. However, they all have due dates. So if you miss the due date, there's a penalty associated with it, which I wrote in the syllabus, 10% per day until you hit the 50% mark. What that means is if there's an assignment other than the exam that's worth, let's say, 10 points, and on day 6, you let it go and you decided to do it on day 6, well, at the maximum number of points you could get would be 5 points because you hit the 50%. So the point being is, if you miss a homework, it's not completely gone. You can still go and get it and get as many points as you can. And because what happens, the homework, we will drop the lowest two homeworks. And you have 14 sets of homework and the lowest two get dropped. So we keep 12. All right, so every chapter is broken down in this manner. So you can see that you have an overview, the textbook, videos associated with that, worksheet, activity, and again, homework for that chapter. So you don't have to be traveling all over Canvas, trying to figure out where your assignments are. They're there for you, all grouped together. You can access them quickly. And also along in the course summary in the homepage. Now, if you scroll all the way down to the bottom, I've uploaded additional resources for you. What these are basically, what they are, there's a table, periodic table, an interactive periodic table. You can click on it. You have to go to their site and click at any of the atoms, and you get a little video about that atom, information about that atom. Pretty interesting little interactive resource. The other ones are simulations that can assist you quite hopefully effectively with respect to the topics that we're going to talk about. For example, we're going to talk about building an atom, about an atom and how it's made up. So this simulation is generated. You click on the atom. We're going to talk about what the atom is made of, which is basically the protons, neutrons, and electrons. So you can grab these particles and actually put them together, and it's demonstrate here what effect it has. That you can see that by, you can see, let me take out the proton. We start off with nothing, okay? So very quickly, I hope you can include something here real quick. I put in one proton, I create hydrogen. I put another proton, I create helium, okay? Now, when I put a neutron in there, I still have helium. If I add another neutron, I still have helium. The blue ones are electrons. If I add one, they go to an orbit, okay? So I can conclude very quickly that what defines a atom is the proton. When I change the protons, guess what? I make a new element. I can change neutrons all day, add, subtract, the element remains the same. So you can build atoms this way, and we can talk about the charge involved with them. We're going to get a lot of this information at length later on, okay? So that's just a little added feature there to help you learn about, to help you simulate a lot of the topics we're going to cover. The states of matter, we're going to talk about that, first chapter, a little bit today. Solid, liquid, and gas. This particular simulation, you can actually see it in action. We talk about the states. We've got solid material. We can heat it up. We can cause it to go into the liquid state, and we heat it up high enough, we get everything into the vapor state, okay? And those little spheres represent the atoms and the molecules of whatever we're looking at. All right. So additional resources. Now, on top of everything, the last module is labeled PowerPoint PDF slides. What that is all the slides I'll be using in our lectures, I have here for you in PDF format, so you can download them and follow them as we go along, okay, making notes and what have you. So you got the PowerPoint slides. I can't give you the actual slides, but I can give you the PowerPoint slides. There's some additional resources here. And as we progress and I find new things, I will obviously forward them to you. Like I said, I sent out a link to a video of a crazy scientist doing some demos. He's pretty fascinating guy. So just some information for you. On the far left, I have StudyMate. What I've done is create we're going to get to a chapter. Oh, yeah, I got to go down. I'll make it available. Where'd it go? Give me 1 second, make it available. There you go. Okay, now it's available. Okay, if I click, there's 143 items in here that I uploaded and created for you. Now, I can have a choice of flashcards or pick a letter, crosswords, but the crosswords don't work too well, but flashcards do. What this is 140 some different compounds. They give you the name of the compound, and if I flip the card, give you the formula. Notice that Canvas doesn't support subscript, so that you get that too. We'll talk more about that because it doesn't support subscript or superscript. This formula will be P subscript to O subscript 5. But there's, like I said, 147, and this will help you with respect to naming compounds as a study guide. Okay, let's close that. Or we can make, matching. And so we start, here we go, phosphorus tribromide, match the formula. Okay. 143 examples. All right, so that's study mate. Let's go over here. Now let's go to the calendar. On the far left panel, we click calendar. Now, if you have multiple classes, come on, calendar. If you have multiple classes, you will see all your classes here, and highlighted would be what is due. So for your class, I took all my other classes out and just put your class. So these are things that are due or coming up. So you can, at a glance, see what's coming up and what's due. We've got an exam on February 2nd, covering chapters 1 through 3. We have an activity that must be done by this week, okay? The Maricopa attendance policy has changed. People must attend the first day of class and or do an activity. And so we need you to get that activity done. And I have a list here of who didn't arrive, so I don't have to drop you, because if you weren't here and you don't do that activity, I'll have to drop you because I don't know all the details, but it's one of the things that came down the tube, so I got to do it. Now, you might ask yourself, well, I didn't know certain things were due. Well, I have reference to this in the syllabus. On the far right, underneath undated, you have what's called a calendar feed, okay? If you click that, the screen pops up. You can copy this link, okay? Copy the link and email it to yourself into whatever electronic device that has a calendar. Email it to yourself, upload it, and what that does, it will load this information into the calendar of your electronic device. So you at all times will have that information, so you can't be surprised and say, oh, I didn't know something was due, and so on and so forth, okay? Also, the other aspect is you can set Canvas with notifications to alert you when things are completed, when things are due. All right, so you should know at all times when things are due. And that way you won't be surprised when something is due, okay? All right, any questions about this part? Feel free to jump in there. You have a question about Canvas itself and what's available for you. Okay. All right. Well, I'll tell you what, I'm going to briefly go to the syllabus because I want to emphasize some information on the syllabus. And then once I do that, if there's no questions, I'm going to jump right into chapter 1. Okay, let's do a new share and let's load up the syllabus. Okay, I emailed the syllabus to you. You also have it on Canvas, so you can download it again if you're looking for it, or you can just view it there in Canvas. First part of information, just my general information. We talked about the email. Canvas email. The course website, there's the link. Everything that's on Canvas, okay, is, let me go back very quickly. Where'd it go? Right here. That link, which is the Canvas. There we go. That is the course website here, okay? Now, everything with respect to in the bottom, top left corner, you got the textbook, the video, the worksheets, all that's in Canvas already for you, but you can access it here. The tables is in Canvas, the shapes table is in Canvas. There's some information with respect to tutoring. I also forward you information through email about tutoring. There's some information about a review for the final. I'll help you out. Now, in here, you will find some more resources with respect to homework and old exams. On the top right, you'll see HW1 through 3. Those are old homeworks that we used to do when we were doing in person. But in there, you also find the key. So homework key 1, 2, and 3. Those types of questions are the same types of questions you will find in your homework, you will find in your worksheets, you will find in the exams. So there's an additional resource for you. In the center column here, you have old exams from 2016. Again, another resource, we have exams with the keys, okay? So none of this is, all this we used to be, all the exams, 1 and 2, those were old exams that we used to do when we were face to face. So all the exams have changed, but the type of questions has not. Okay, so this is an additional resource. And then the syllabus for all the instructors, quite a bit of instructors here. So, all right. Let me go back to, and that's that website link right here, course website. Okay. Now, you guys are here 4:15 to 5:30. Now, I also teach a class at, same class from 1 to 2:15. If you find sometimes you can't make the 4:15 or you want to come to get more information or get it again, feel free to come into my 1 o'clock. I have no problem with you doing that. Officially, you're at the 4:15 class, but unofficially, if you want to come to the 1 o'clock to get more information, you're more than welcome. I also teach at SEC on Fridays, and all 3 sections are using the same textbook, everything about the same. You're welcome to come to that session. That's between 1 and 3:40 on Fridays. Same link that you find on the Canvas, get the same Zoom link, get you there, okay? And if you can't get, if you want, I gave you the meeting ID information and the passcode if you're using the app directly. All right, so our final exam, May the 11th. So mark that calendar. It will open, that exam will open from 12 p.m. until 11 p.m. If there's a problem with respect to making that time period, again, I emphasize, let me know ahead. We can make other arrangements if necessary. For course competencies, basically what this is telling you, these are 29 different topics that we're going to discuss over the semester as per Maricopa policy. So that lists that. Okay. Attendance requirements. A lot of people have asked me, "What is this a requirement?" Well, my answer is, I answer it this way. If you were doing live, if we were on campus, would you come to class? Well, some would say no, some would say yes. So I treat this as, even though we're doing virtual, it's still face-to-face from my perspective. So it's on you. But I do know I do have parameters that I have to keep track because we're online. And as per Maricopa policy, if you don't participate, 14 days of non-participation, consecutive days, then I have to withdraw you. What that means, participation means either you come to class or the Zoom class, or you're online doing something, and not just log in and then go out, but log in and doing an assignment. Okay, so I do have to go and check. So don't. And if I see you at that area, I'll shoot you an email to just kind of remind you, hey, maybe you need to go in there and complete something. All right. There's a time limit that we can withdraw. More on that here in a second. Our grade scale, standard 90, 80, 70, 60. Okay. We have activities, which are worth 25% of your grade. Your homework is worth 25% of your grade, of which 2 of the lowest are dropped. You will have 5 exams, okay, which are worth a total of 30%. And then we're going to have the final exam, which is comprehensive. Comprehensive meaning it encompasses all the chapters, and that is worth 20%. Okay. The calendar feed, I did talk about that here. If you need to figure out how to do it so you can download your calendar to your electronic device. I talked about the penalty, and it's for assignments excluding the exams. This is for your activities, homework, and the others, not the exams. But there is a 10% penalty per day, meaning that at the 5th day, after the 5th day of lateness, you're down to the 50% mark. And that's the most percentage of points you can get as a penalty. Now, if you miss an exam because it just simply didn't work out, we couldn't make arrangements for alternative times. If you miss an exam, no worries. Don't get too tied up real bad, because I can take the final exam score and replace that score into any of the exams that you miss, okay? So that option is there. Now, if you miss the second one and we can't make it up, I can't do that. So it ends up with a 0 point. So obviously you don't want to miss a second exam, because your point average will drop pretty quick. Okay, you can only make up 1 exam. Academic integrity. This is pretty self-explanatory, but one of the key things is this. We've been doing now online since, well, last spring semester, about halfway through. And so we had the summer all online, and then this past semester, fall semester, all online. So we gained a little experience on how to present this. We're always open for more suggestions, obviously. But one of the things we found was, remember this, we are doing chemistry 130 level, okay? The complexity of chemistry can be we can get into very complex chemistry, which is like things like what we call quantum mechanics, which is way beyond the scope of this class. However, some people would actually go online and research an answer and copy and paste a very elaborate explanation, which is beyond the scope of 130. Now, I'm not saying you don't have that information, but if you do, please enlighten me why you feel if you pick that answer with quantum mechanics connections, because I'm versed in quantum mechanics. We can talk. So basically what was happening is doing a cut and paste, okay? Don't want to do that. There's nothing wrong with researching something. Okay, you have a large vast of resources to look up information. Okay, take that information, put it in your own words, and submit that. Okay, don't copy and paste an answer that has been copied and pasted 100,000 times throughout the internet. Okay, use your own word, because that's called plagiarism. You don't want to do that. So use your own words. All right. Also, what we do is we look every time you take an exam, we emphasize the exams. The homework, you got to look stuff up, and there's no question there. Activities, no question there. It's during the exam that we look at what's called the log. Every time you leave that page, that window in your browser, Canvas makes note of it. So that infers that you're out looking for stuff, okay? And so, yes, occasional lag, something happens with your internet, boom, not a problem. But I had, last semester, I had 2 examples. There was about 85 flags. That meant that that person went back and forth the internet 85 times during that exam to look up stuff. Okay. Don't do that, okay? Don't do that. All right. The questions are pretty straightforward. I try to get you prepared for them. You get a lot of resources. A lot of times, the vast majority of the questions are multiple choice. And by deductive thinking, you can come up with the answer if you don't know what that answer is, okay? Based on what you learn. All right, so a couple of things. Here's our tentative schedule. Now, why do I call it tentative? Because the homework is, we got due dates on them, but those are a little bit flexible because I'm not going to make a due date on a chapter that I've not completed, okay? And so if we fall behind because people don't quite get the topic, I have no problem with slowing down and making sure that you understand that topic before we move on. Well, it may put us behind. No big deal. I just move the chapter due date. Okay, so those, some flexibility. The ones that don't have flexibility are the exams. Those are set, etched in stone. So there's the date for you. This is the week. Because our Chem 130 week starts at Saturday. It starts Saturday and goes through Friday. So that's why we got a range here in the date. We have spring break, March the 15th through the 20th. Don't party too much because when you come back, you got a test. All right. So be ready for that one, Tuesday. And then our last exam is about a week before the final. And that will encompass chapters 13 to 15. Now, the way this works, it worked out pretty good last semester and semester before. During the exam days, if there's those days, I'm open to, if you have any questions concerning the chapters that you're going to take the exam on, okay? I have no problem with, let's talk about it in class. But if there isn't, I continue with the chapters, okay? The result is when we get down to, say, the last week or two of class, we're going to have a lot of we're going to probably finish chapter 15 a little bit early. So we're going to have a lot of what we call study days, open days, which I'll be here, but it'll be open for whatever questions you may have, okay? And so we can pick up maybe 2 or 3 study days toward the end of the semester. And it all depends during the exam day, if you have any questions. If no questions, then I proceed with the next chapter. I continue with the chapters. First couple of weeks is going to be a little bit fast paced. I'll get you going. Then after that, kind of slows down to about once a week. You have something due. Okay. Any questions so far? Comments, concerns? All right. And basically monitoring, we're not monitoring anything other than looking at the log. The rest of the information here is for your reading at your when you have time, go through this, a lot of information. There's also resources, student resources on Canvas if you need some help. Some etiquette, you know, if you have a question, I have a problem with unmuting yourself and ask the question, or you can run it through the chat. Sometimes the chat, I get carried away with the talk that I forget to look at the chat when to alert me. So feel free to unmute yourself and ask the question. Okay. There's also a raise your hand function there someplace. I've not used it. So it's in there someplace. You can raise it. It's supposed to alert me when somebody asks a question. All right. So I didn't put you to sleep too bad, did I? All right. Any questions, comments, concerns?
Yeah, I have one.
Sure, go ahead.
On the tentative class schedule, the corresponding lab, is that available from this class page, or is that through the Chemistry 130 lab class?
Yes, the lab class. The lab,
Okay.
what we've done is we put the lab in the schedule to kind of to give you an idea. We try to maintain the chapter with the lab, but the labs, as you know, are separate. You have your own instructor. I'm not teaching labs this semester, so I don't have any lab classes. So if you haven't been contacted by your instructor, I would contact them through Canvas email. Okay, I'm assuming they published the labs already. You should have two, a Chem 130 and a Chem 130 double L.
Yeah, I'm looking at the lab one right now. Thank you.
Yeah, send them an email. But that does correspond, and I can tell you this, I do know this much about it, that it's a weekly lab. It'll be due. Okay, so you have, like this week, you have something to do. There's some safety, something having to do with safety. Okay.
I'm comparing them right now. Thank you.
Yeah. Any other questions? All right.
I have one.
Sure, go ahead.
You mentioned being able to replace an exam with a final exam grade if we have to miss it for some reason. What if we did really poorly on one exam but did really well on the final exam? Would you replace that?
Good question, but I can't do it. Okay.
Okay, you can't do that.
Yeah, but let me clarify this. If you miss any exam 1 through 5, I can take the final exam for one of them and replace it, any of the 1 through 5.
Okay.
If you miss the final exam, that's a 0. I can't do anything for that.
Just 1 through 5.
Yes, 1 through 5. Yes, that's correct. But no, I don't have the latitude to, I did better this one. Can I replace it? I'll bring it up at the board meeting next time and see what they say.
Okay.
Because I'm governed. You can see in the course website, there's I forget how many sessions for Chem 130. It's not like my single class I can run. I'm governed by, I forget how many class sessions. There's 15 instructors in the GCC. There's quite a bit. It's a lot of classes offered. It's even bigger than some universities when you think about it, GCC. When I do SEC, there's only 3 professors and 2 adjuncts. I'm one of the adjuncts. In GCC, there are 8 professors full-time and 8 adjuncts. It's a big class, a lot of people. Okay.
I got a question.
Sure, go ahead.
So with regards to the activities, do you have to record yourself doing every activity for each chapter or just the welcome?
No, just the welcome. The welcome is just that one thing. No, you don't record yourself for the activities. Each one after the welcome is something else. It's just called activity. It's something like you have to download a data sheet and then look at a video and then transfer that information to that data sheet and then upload the data sheet after you take a picture of that and convert that to PDF. But the first one is just a hello. Or some activities may ask you explain molarity. Then there you would do a self-explanation of what you think molarity is. I know you don't know what it is now, but that's an example. but you will.
Okay, sounds good.
Okay.
Thank you.
Okay. All right. Any other comments, concerns? No. I'm gonna share with you another slide. Let me make sure I got the right one here. It's a concept in chemistry that kind of surprises people. Okay. It's related to the conservation of matter. The conservation of matter says that we don't destroy matter, we just move it around, we convert it into something else. And we've done experiments to demonstrate that. We can't do it here, obviously, because I wanted to do something in my kitchen, but I've been told no, stay out of my kitchen, so I can't blow that up. All right, so I put the slide together to kind of give you an idea about what I'm talking about, and it's all going to be related here. It's going to be kind of weird here for a second, but it's all related eventually. That is one thing about all these chapters, is they're all tied in together. And not all the not all the information is tied in, but they're all connected. So eventually, when we get to the latter chapters, I'm going to try to put everything together and see how everything's kind of tied in. Okay. And hopefully it'll enlighten you. Let's take a look. Let's take a look at carbon. Okay. What I've done here, I got a picture of a grass. Okay. And I put a letter C in yellow to represent a carbon atom that is incorporated somewhere in that leaf of grass. It could be in the form of leaf, a sugar. It could be anything in that form of that particular lettuce. Excuse me, not lettuce, but leaf. Okay, incorporated in there. Well, what do we know? Now, my apologies to the vegetarians, but what do we know? Who likes grass, right? All right, here comes a cow, eats the grass. That carbon atom that was in some kind of form of structure now is incorporated into the cow. It got broken up, and then it was used as energy into the cow. Now it's maybe tissue in the cow, still the same carbon. It just changed form. Okay. Now, what happens? Well, what do? When I eat the hamburger, again, my apologies. My partner's a vegan. She's like, oh, I don't like this slide, but I'm going to have to change it. Okay. But what happens? We eat the cow. Okay. That same carbon now is incorporated in you in some form. It could be a muscle tissue. It could be anything, but it's still carbon. Now, the key thing about it is we're going to learn that carbon is made up of 6 protons. We'll talk about that at length. But when it was in grass form, it still had 6 protons, still carbon. When it got into the cow, it still had 6 protons. It's still carbon, different form. When it gets into the human, guess what? It still has 6 protons, but now it's in a different form. Now, the human has metabolism, and one of the things that we exhale is what? Carbon dioxide. Do we not? We exhale. That's why you want to talk to your plants, right? Why do you talk to your plants for? Other than psychological reasons. You have carbon dioxide because the plants need carbon dioxide, right? And guess what? The carbon dioxide goes back into the atmosphere, picked up again. Well, wrong direction. Picked up again by the grass, and the process continues. Same carbon. Now, CO2, same carbon, 6, same number of protons. It hasn't changed. It has changed structurally, but that atom still remains the same. And that is what we call, that's what fascinated me about this when I first started, way back when. Ironically, I was a business major 100 years ago. And then I became a medical technology major. And I wasn't too crazy about that, so I changed to chemistry. My first chemistry class I took, I flunked. Seriously flunked. Big ol' F. I don't know how I got a doctorate in it, but I do. But the big difference was the way chemistry was taught, okay? And I was fortunate enough to go to a university, a college at the time, run by some nuns that really had a good way of teaching. And I hope I can forward this to you. Now, I understand you have different majors here. So I think the majority are probably nursing students. That's what I get every semester. The majority are nursing students. Probably got some engineers in there, a variety of different majors. I understand that I'm not here to make you into a chemist, okay? However, I hope that you can take away maybe a greater love of learning, teaching you how to learn and how to deduce information. It is one thing to sit there and regurgitate knowledge because you memorized 10,000 facts, but it's quite different than taking that information you memorize and applying it to different systems. So problem solving, we're going to go through that. There's a lot of things about chemistry that you already know, but it's never been brought forward. Okay. And so having worked in industry, I kind of bring a different kind of a twist to teaching. Some people like it, some don't. It's okay. If you, feel free to find somebody that clicks as far as the way you learn. I tend to use a lot of examples, real world examples to help you learn about the concepts of chemistry. Okay. So with that in mind, let's jump right into it. So what is chemistry exactly? Okay. Chemistry is quite straightforward. It's a study of matter. We boil down to it, study of matter. We study the composition of matter. We study the structure. We study the properties of matter. We study the changes they undergo, physical changes and chemical changes. Okay. Well, what do I mean by physical changes? Well, you already know of a good physical change. You got ice, H2O, it's water. What do you do when you take that ice cube out and you put it in your cup after a while? It melts, right? Goes through a liquid. Guess what? It's still H2O. You didn't do anything. And if I take that cup of water that used to be ice, now it's liquid, and I put it in under some heat, guess what? I'm going to heat it up and boil it, and it's going to go into the vapor. So you went from solid, liquid to gas, but you did not change anything chemically. It's still H2O, okay? Now, if I take baking soda, you're all familiar with baking soda, and I take Italian dressing, and I mix the two, I get bubbles. Well, I get bubbles because in Italian dressing, if you didn't know this, you're eating vinegar, which is an acid. Okay, that's what gives it that sour. It's an acid. I'm going to ruin your food taste for a while because I'm going to tell you what you guys are really eating. Okay, you may not have known that, but hey, you're eating that. So you get the baking soda, you get the Italian dressing or the vinegar, they react. You have a chemical reaction because you have bubbling going on and you change the structure. See, that's the main difference that when we talk about physical and chemical changes. In a physical change, you don't change the structure. You just change the state of matter. In a chemical change, you change the structure completely. Okay. Now, we have determined that all matter is made up of what is called atoms. Now, that's not a new concept. The Greeks had that concept 100 years ago, 1,000 years ago, whenever they were around. But we've taken that concept and fine-tuned it a little bit better. Okay, because we learn more information. So we're going to learn about atoms, and we're going to learn about what these atoms are made up of. And there's 3 subatomic particles that we're going to be talking about. Okay, and we're going to be talking about protons, neutrons, and electrons. Those are the 3 basic components of what makes up atoms. Now here's the, remember I showed you that link where I was sticking the atom, I was sticking the proton, I was creating a whole new element. That's the fascinating thing about this. Can you imagine this? You know, a good example would be Legos. You know, if I had a million Legos, all the same color, same shape, I could, you know, if you let your imagination go out, you can build all kinds of different things, right? They all look differently, but they're all built from the same little unit. And that's what those crazy protons are. The protons are all the same unit, but by changing the protons, a number of them, I create a whole new element. There's 118 elements if you check that periodic table. 118 different elements. And the only difference between, there's a lot of differences, but the main difference between number 1 and number 118 is number 1 has 1 proton, number 118 has 118 protons. Because the proton defines what that element is. Now the neutron and electrons, we lose those, we can lose and gain those all day, but we don't change what that element is by doing it. The electrons really got me excited about chemistry a long time ago because they're involved in so many things. Now, you wake up in the morning, your hair is like this. Boom. Had a bad hair day, right? Your hair's all on the poof. Or you put on a dress or a pair of pants and it clings to your body. Or you're shopping and you're pushing a cart and you touch something, you get zapped. Or you walk on carpet and you touch something, you get zapped. All those things that do all that, those are electrons all around us. There are electrons all around us. And they have such a, they're so tiny and so small that they have a property of acting like light, and yet they're particles. And they have a tremendous effect on what the property is of an element. For example, sodium. You all know about sodium. When you hear sodium chloride or salt, you think, okay, I put that in my French fries. Okay, let's just talk about the sodium. Sodium that you put in your French fries is missing 1 electron. There's another sodium that's not missing that electron, that if you put that on your French fries, you're going to get an explosion. If you were to put that in your mouth, it would get so hot, you made a lot of heat, a lot of hydrogen gas, it will explode in your mouth. Whereas if you put sodium chloride on your tongue, okay, it'll be okay. It might affect your blood pressure. And the only difference between the element sodium and the ion sodium is 1 tiny, tiny electron. Big difference. All right, so those things make up the protons, the neutrons, and electrons make up what we call the atomic mass. Okay. Now, we're going to talk about chemical bonding. And and again, we're back to the electrons. And of all the chemicals out there in the world, there's only 2 types of chemical bonds. We got one type where the electrons are being shared. And then we got another type where there's an attraction like 2 magnets coming together. There's no sharing going on. That's it. Of all the chemicals in the world, that's all we got. We have a whole chapter on that. Then we're going to talk about reactions. When we mention a reaction, there's a big reaction. You're familiar with the reaction. Okay, you ever made chocolate chip cookies? Okay, does anybody put baking soda in their chocolate chip cookies? Why? Other than the recipe says to put them in. Okay. Or you make bread. Why do we put bugs in the bread? I call them bugs, but it's not. They're small guys. Okay. Why do we put that in there? Anybody know? Why do we put baking soda in our chocolate chip cookies?
Because it changes the bonds inside of the material. It changes it chemically.
What? There is a change of chemicals, yes. But what happens is baking soda, when it's heated, decomposes. And when it decomposes, guess what? It makes carbon dioxide. And when carbon dioxide then causes your cookie to rise, just like you put yeast, not yeast, what do you call that in bread? Having a senior moment. To make your bread rise. Yeast. Same, yeah, yeast. Yeah, right. Let me wake up here. Why do you put bugs in bread?
To make it rise.
Yeah, well, why is it rise though? Because the yeast is a living organism.
I didn't know that.
Yeah, okay. But you're correct. The yeast eats the sugars in your bread and so forth, breaks them down. And like that slide I had before where the human ate the hamburger, then after a while metabolizes a gas, the yeast then breaks the sugars of the bread down. And one of the byproducts in its metabolism is carbon dioxide, which causes your bread to rise. It's a chemical reaction. Without the yeast, you have unleavened bread or matzah, okay? Flat bread or flat chocolate. Try it at home, do an experiment, do chocolate chip cookies with or without baking soda. Yeah, there you go. You got any kids, you can help them. I tell them you're going to do an experiment, see what they come up with. So that's the chemical reaction, okay? And we're going to have lots of chemical reactions. But when I say lots, I'm talking about of all the chemical reactions that we have in chemistry, we only have 6 types. Imagine that. Millions of billions of chemicals out there, but there's only 6 types of reactions. If you drove your car today to go to point A to point B, you did a combustion reaction. That's one reaction. Okay. And if you made chocolate chip cookies with baking soda, that's another reaction, decomposition reaction. And if you ever take that same baking soda and dump it on vinegar, that's another reaction called neutralization. And there's a couple more, but we're going to have a whole chapter on that. We're going to talk about the periodic table, okay? Now, if you haven't downloaded that table, please make reference to it because we're going to use it quite a bit. We are, just by looking at the periodic table, you're going to be able to tell me, you're going to be able to just look at where the atom is and determine things like, okay, how many total electrons it has, how many protons it has, how many neutrons it has. If it's compared to another element, you can even determine if it's bigger or smaller. You'll be able to look by its position in the periodic table, whether the element is a liquid or a solid or a gas, okay? Or then by looking at its position or periodic table, you're going to be able to determine whether that element is going to lose or gain electrons. Okay, just by finding its position in the periodic table. So we'll be using it quite a bit. So if you haven't done it, go ahead and make sure you download it. Acids, bases, and electrolytes. Okay, well, what's an acid? Well, you like Italian dressing, you're eating a lot of acid. Okay, vinegar, for example. Right now, as you sit in your stomach, you have an acid called hydrochloric acid. Its form is HCl, lowercase l. Okay, your stomach is a very low pH, very acidic. And if you make too much acid, what do you normally take? What kind of things do you take? What could you buy over the counter to reduce
Antacid.
Antacid, things like Tums, Malox. Guess what that is? That's a base. So when you ingest that base, you neutralize the acid content in your stomach. And then electrolytes, a good example, like I just said, the sodium example, where sodium with its electron, sodium without its electron, electrolytes are nothing more than the elements that either have gained or lost electrons, okay? And they're important. They're important in your body. They're important because they conduct electricity. Without electrolytes, you couldn't get your heart to beat. You couldn't get your blood to coagulate. You couldn't even breathe, okay? Your cell phone wouldn't work. None of this electronic equipment, if you were running off a battery now, wouldn't work, okay? So electrolytes are very crucial. That's why after a workout, what they ask you to do, drink some Gatorade or drink some Pedialyte because they're loaded with electrolytes. We're going to talk about what's called the mole, AKA mole, but not that mole, the mole, okay? The mole is simply nothing more but a number. It just happens to be a big, gigantic number. When I say to you, a dozen, what number you think of? 12, right? So the mole is nothing more than the chemist does. It just happens to be 6 and then move the decimal point over 24 times to the right. 6.02 and move that decimal point over 24 times. That's a big number. We'll get a lot more to say about that. Okay, here's a fancy word for you. Stoichiometry, okay? You're already familiar with it. If I got a unicycle frame, how many tires do I need? 1, right? It's a unicycle. So that the relationship between the frame and the tires are 1-to-1. That's the stoichiometry. If I got a bicycle, the frame to the tire ratio is what? 2, right? I need 2 tires, unless you want to make that bicycle into one unicycle, but I need 2 tires to that one frame. And if I have a tricycle, guess what? 3, right? And if I'm driving a quad, obviously your car, I got 4. That is stoichiometry, because you will find that reactions don't always just occur a simple 1-to-1. Sometimes it could be a 1-to-2. Sometimes I need 2 of A to 3 of B. You know, that is a stoichiometry. Now, why do we need that? Well, we need that because we're going to be eventually doing calculations. And we need to know that stoichiometry. More on that as we go down. Okay, intermolecular forces. All right, I got a cup of water and a cup of honey. And I take them and I empty them. Who's going to win the race? The honey or the water?
The water.
Of course, the water, right? Because the water is not as viscous. The reason the honey is so viscous is because the intermolecular forces, that is, the interactions of the molecules of honey, are much stronger than the interaction of the molecules of water. Now, I can make that honey run a little bit faster by heating it, right? If I heat that honey, I can make it flow just as fast as the water does. And guess what I've done? By heating it, I've broken up those intermolecular forces, okay? Then we're going to talk about solutions, and then if we have time, we'll talk about gases. I don't know if we're going to get into that's an optional one, the chapter 16. I don't think we'll be doing it. Okay, branches of chemistry, like any other field, you know, engineers, you got your mechanical engineers, you got your chemical engineers, electrical engineers, doctors, you got your pediatricians, surgeons, you know, brain surgeons, orthopedics, so forth. Chemistry is the same way, okay? We have a variety of different groups or branches of chemistry. Inorganic, which basically, as it states, is dealing with mostly metals, a lot of non-organic compounds, mostly organic. My background is organic chemistry, building, synthesizing compounds. And one reason I like that is because as I stated before in my intro, I used to work in construction, like to build things. And when I get into chemistry, organic synthesis is nothing more than building molecules. They just had to be much smaller. So I just clicked in. And biochemistry, dealing with the chemistry of life. Physical chemistry, those are people that just simply want to study the physical aspects of chemicals and chemical reactions and so forth. And then you have Dr. Kim, her doctorate's in chemical education. And of course, we have a very important field called environmental. I understand the chemistry involved with respect to our environment. And then the analytical chemists who were very meticulous about measuring things, very meticulous. All right, so, and that's just a tidbit. There's other groups in there. All right, now why chemistry? Now, I would not tell you that chemistry is the most important course in your life. No, it's not. But I can tell you this, chemistry affects literally every aspect of your life. Yeah, either directly or indirectly. Chemistry is involved to do a variety of things, even food. There's scientific journals that utilize study food. You know, the chemistry reaction of chemical reactions of cooking. Okay, but just a few examples of things that occur that chemistry is involved, but that's just the tip of the iceberg. Okay. Now, as scientists, we utilize what's called the scientific method. And it's broken up into basically 4 steps. The first step is, hey, I make an observation. You observe something, okay? And so as a scientist, you're curious. Okay, I observed it. So let's take an example and we'll say, okay, you took a soda bottle and you stuck it in the freezer and guess what? It exploded. All right. So you say, I create a hypothesis. You ask yourself, why did it explode? Why did it explode? So you create a hypothesis. Okay. And it's just a guess as to why you think it exploded. And you come up with the idea that, okay, the liquid must turn into ice and it must have expanded when it freezes. That's my hypothesis, that ice expands when it freezes. Okay. And so you go through the literature, find out if other work has been done, check the resources. And if not, then you may want to set up some experiments. Okay. So you might try different things. You might try different volumes of liquid. You might try different soda types, different containers, different temperatures, freezing temperatures. You want to be at freezing or way below freezing or close to freezing. Do a variety of things to test your hypothesis, okay? And then after that, you analyze it, after you look at your results, and then if necessary, repeat the experiments with more experiments to verify it, or different experiments to verify it. And then at the end, you draw a conclusion. And hopefully that conclusion then will be published in a scientific paper, and then other scientists around the world will take that and try to repeat it, see if it repeats itself, and go from there. So that's basically the scientific method. We're using 4 steps here: observations, formulate hypothesis, research a hypothesis, perform experiments, and 6 steps: analyze it, the hypothesis under your experiments, and then draw a conclusion. Make good observations. If you are in the lab, you'll be looking at a lot of videos. So very specific as far as your observations are concerned, and to the exact, to be as exact as possible. Things like color. No color is colorless is not necessarily clear. Clear, it's a description of clarity. Okay, I hope that makes sense. There's a difference. You can have a color solution that is not cloudy, okay, or vice versa. And look at the state of the matter. Was this material solid or is it a liquid? Did it go into a gas by forming bubbles? There was temperature given off while the reaction proceeded. So things of that nature. So very crucial. Making observation skills are very crucial. These are things that you can hopefully pick up. And if I don't want to pick on the nursing students or pre-med students, but observations are very crucial in your field. Very crucial in watching your patients. Okay. Anyway, as I stated, matter is anything that has mass. And you know what? I have gone above and beyond here. I just noticed the time. It's 5:32. All right, so I am going to stop it here. And page 8. Okay, let me stop it here. Anybody have any questions? comments? If not, I'll see you guys on Thursday. And let me stop the recording.